Hey everyone, and welcome back to the Foundry by Forge College. Today, we are putting on our hard hats and stepping right into the role of senior architects. Now, if you caught our previous explainer, Framing Problems Suited for Blockchain, you know we talked a lot about how to identify the specific traits that make a problem actually right for distributed ledger technology. But, theory is one thing, and the real world is a completely different beast. So today, we are taking a hard look at real-world industry blueprints to see if blockchain is truly the right foundation or if we're all just pouring incredibly expensive digital concrete for absolutely no reason.
Okay, let's take a quick look at today's blueprint. We're going to start with our primary evaluation lens, then move into 3 actual field inspections, do a quick code walkthrough under the hood, and wrap it all up with your key architect takeaways.
Section 1. Inspecting the blueprints using our evaluation lens. And listen, we really need to remember a fundamental truth of engineering here. Blockchain is not a hammer for every single nail.
It's a highly precise tool. So, what is this lens we're talking about? Well, the blockchain lens is really a philosophical framework. We use it to evaluate trust boundaries, as in who actually trusts who in this setup. We look at observability, who gets to see what data, and mutability expectations. Does this data actually need to be permanently locked? We aren't just asking, hey, can we plug this tech in and make it light up? No, we're asking if deploying this specific technology brings a distinct, measurable advantage to the problem. Does it minimize trust where trust is super expensive? Does it align incentives where they're naturally pulling in opposite directions?
Think of this rubric as your ultimate inspection checklist. We're analyzing 4 key criteria: conflicting incentives, public verification, data privacy, and protocol rules. You use this to quickly weigh the absolute must-haves versus the nice-to-haves. For instance, if you have highly conflicting incentives, then a public trust-minimizing architecture is a fantastic fit. But what about data privacy? If your data is incredibly sensitive, that completely changes the game and favors an off-chain or permissioned approach. You use this lens to separate out the brilliant, game-changing innovations from the frankly terrible ideas, like, putting someone's private grocery shopping list on a permanently immutable, globally public ledger. Literally no one needs that verified for all eternity.
All right, let's transition to our first field inspection. Case 1, supply chains, and specifically looking at provenance for high-value goods.
Grab your clipboards for this one. Imagine items moving across multiple borders, passing through the hands of competing manufacturers, shipping giants, customs, the whole shebang. We have a massive trust boundary here, totally filled with competing incentives. Everyone wants to maximize their profit, and unfortunately, fraud is a real issue. So public verifiability of origin certificates, huge win. It slashes fraud and builds real consumer trust. But wait, here's the major catch. Absolutely no company on earth wants their private commercial terms, their pricing agreements, or their sensitive logistics data broadcasted to their rivals on a public network. No way!
So the crucial takeaway here is that we absolutely need a hybrid approach. On-chain, we only keep the provenance hashes and the tamper-evident proofs. It's kind of like a cryptographic wax seal. Then off-chain, tucked securely behind traditional access controls, we keep the full records, the sensitive commercial terms, and all that detailed sensor data. Basically, you anchor the truth publicly, but you hide the actual cargo privately.
Let's move over to our second blueprint. Case 2 takes us into trade finance and cross-border letters of credit. We are stepping out of the shipping yard and into the banking sector. This is a very complex legacy world. You've got exporters, importers, banks, insurers, and historically, incredibly slow, paper-heavy reconciliations. Because all these independent parties suffer from these massive reconciliation costs, this scenario is screaming for trust minimization and legal finality. The multi-party distrust perfectly fits our philosophical rubric, but, and this is a big but, something we emphasize heavily in our blockchain fundamentals track at Forge College, you're going to run headfirst into a massive structural wall: strict regulatory compliance. You see, you can't just deploy a Wild West public ledger when global financial rules demand strict identity verification and localized data controls. It creates a massive architectural dilemma. A fully public ledger maximizes trust minimization, sure, but it completely lacks the legal integration needed for this specific sector. On the flip side, a permissioned network gives you standardized APIs, known participants, and actual regulatory compliance. So, for trade finance, a permission network is almost always the winning architectural blueprint, simply because the current legal frameworks just aren't ready to accept public, permissionless settlement for these types of instruments.
Time for our final field inspection. Case 3, land registries and tamper-evident national titles.
We are looking at public infrastructure here, where citizens and governments desperately need a tamper-evident record of property titles to prevent land theft and boost the economy. And there is a golden rule in this space. I love this quote. Without legal alignment, the ledger becomes an auxiliary record that may increase complexity without altering real-world property rights. Think about that. All the beautiful, mathematically pure engineering in the world means absolutely zero if the local courts don't recognize your blockchain token as a legal transfer of the physical dirt and bricks. Without the law backing it up, you just have a really fancy digital receipt and someone else is still living in your house.
So while a blockchain land registry brilliantly reduces corruption and makes title searches a breeze, systemic legal acceptance is the ultimate gatekeeper. Furthermore, you absolutely must engineer clear mechanisms for historical corrections. Look, humans make typos, bureaucracies make errors. If an immutable ledger accidentally assigns your family farm to a total stranger because someone hit the wrong key, and there is no governance process to reverse that error, well, the system has completely failed the philosophical test of utility.
Let's head into Section 5. We've talked a whole lot about balancing public proof with private data. Let's look under the hood at the hybrid architecture pattern that actually solves this.
The technique is called anchoring. It means storing only a cryptographic hash and a timestamp on a public ledger while keeping the sensitive, full-size document entirely off-chain. I love using a physical analogy for this because it hits the nail right on the head. It's exactly like tying a boat to a public dock. Everyone walking by on the pier can see the rope, they know you arrived at 2 p.m., and they know you claimed that spot first. But your actual cargo, that is locked safely and privately below deck. Let's walk through the pseudocode logic step by step. Step 1, we create a minimal anchor structure in our smart contract. We're talking just the submitter's identity, the timestamp, and a short reference tag. Step 2, we map the cryptographic hash of our private document to that anchor. Step 3 is absolutely crucial. The contract checks for duplicates to enforce a strict first seen rule. This proves you were the original creator. And finally, Step 4, we emit a public anchored event so external auditors can independently verify it without needing permission. Notice how we're keeping the on-chain data footprint incredibly small here. This preserves your privacy and keeps your scaling costs dirt cheap.
And that gives us our hybrid architecture. On-chain, we only enforce the unbreakable rules: the first anchor, the timestamp, the unalterable proof of origin. Off-chain is where all the heavy lifting happens: your proprietary business logic, your complex workflows, and those messy integrations with real-world legal systems. This clean separation of duties, that is the absolute hallmark of great blockchain architecture. It places responsibilities exactly where they belong.
All right, architects, it's time to roll up our blueprints. Let's cover our key takeaways and the final review.
Let's distill this into 3 core heuristics you can take right back to your own engineering desks. First, always prefer the anchoring pattern when you need public verifiability but demand private, sensitive data. Second, make sure to match your system's governance to the legal context of the real world: public for trustless environments, permissioned for heavily regulated ones. And third, please never confuse technical feasibility with philosophical fit. Just because you can build a ridiculously complex decentralized protocol doesn't mean you should, especially if the real-world social or legal levers just aren't there to back it up.
So, I'll leave you with this provocative thought to chew on. Look at your own projects. Is your industry actually ready for the blockchain lens? Or are you just looking for a really expensive, highly complicated database? Be honest with yourself. Think deeply about your own industry scenarios as we move forward in this real-world applications module. To dive deeper into these mental models and to explore more explainers on blockchain fundamentals, I highly encourage you to visit forge.college. It really is an incredible educational resource. Thanks so much for joining me for this explainer, and I will see you in the next inspection.